Welcome back to the Pre-Calculus Mastery Program. In our previous lesson, we explored the graphs of basic functions. We saw how linear functions form straight lines, quadratic functions create parabolas, absolute value functions form V shapes, and cubic functions create smooth S curves. But now an interesting question appears. What happens if we change the function slightly? Will the graph change completely or will it simply move to a different position? In mathematics, graphs behave like objects that can slide, flip, stretch, and shrink. These movements are called transformation of functions. Today, we will learn how functions move on a coordinate plane. And once you understand these movements, you will be able to predict how a graph changes without even plotting many points. Before studying transformations, we start with something called a parent function. A parent function is the basic form of a function before any changes are applied. For example, the parent quadratic function is f of x is equal to x square. Its graph is smooth U-shaped parabola centered at the origin. All transformations start from this parent graph. Now let's look at the first transformation, a vertical shift. Consider the function f of x plus 2. Here we are adding 2 to every output. This means every point on the graph moves 2 units upwards. The shape of the graph does not change, only the position changes. If we subtract instead, for example, f of x minus 3, then the graph moves 3 units downwards. Now let's explore horizontal shift. Consider the function f of x minus 3. Here, subtract 3 from every input x. This transformation moves the graph 3 units to the right. Even though the number is negative inside the parenthesis, the graph moves to the right. This is common pattern in mathematics. Similarly, f of x plus 2 moves the graph 2 units to the left. So, horizontal shift move the graph sideways along the x-axis. Another transformation is called a reflection. A reflection flips the graph across an axis. If we multiply the function by negative 1, for example, negative f of x, the graph flips upside down across the x-axis. And if we replace x with negative x, for example, f of minus x, the graph flips across the y-axis. Reflection creates a mirror image of the original graph. The final transformation involves stretching or compressing the graph. Consider the function 2 times f of x. This multiplies every output by 2. The graph becomes taller and steeper. This is called a vertical stretch. Now consider 0.5 f of x, that means 1 by 2 f of x. The output becomes smaller and the graph becomes flatter. This is called a vertical compression. The shape remains the same, but the graph becomes stretched or squeezed. In real mathematics, transformation often appears together. For example, f of x minus 2 plus 3. This means the graph moves 2 units to the right and 3 units upward. Understanding transformations allows you to predict the graph instantly. This skill becomes extremely powerful in calculus and advanced mathematics. Today we explored the transformations of functions. We learned that graphs can move in several ways. Vertical shift move the graph upward or downward. Horizontal shift move the graph left or right. Reflection flips the graph across an axis. Stretching makes the graph taller and compressing makes the graph flatter. These transformations allows us to understand how functions behave and change. Describe the transformations in the following functions by your own and try sketching how the graph changes. When you understand function transformation, you begin to see graphs as a dynamic object that move and change. And this ability to understand changes is exactly what calculus is all about. Thank you for learning with me today. Keep practicing, and I will see you in the next lesson.